just fine before I met you.
The International Union of Pure and Applied Chemistry is the world authority on chemical nomenclature and terminology, including the naming of new elements in the periodic table, on standardized methods for measurement, and on atomic weights and many other critically evaluated data. Nomenclature in organic chemistry is very, very important because every day new compounds such as hydrocarbons are made, and it is important to keep track of all of them by naming them correctly in an organized way.
Hydrocarbons are organic compounds made up of only carbon and hydrogen. We can classify them depending on the arrangement of their elements, and it can be in alkanes, alkenes, alkynes, and aromatics. Let's begin first with alkanes. Alkanes are hydrocarbons that have single bonds between the carbon atoms. For you to identify better with the formula of a hydrocarbon to know that it is an alkane, you can use the general molecular formula of alkanes, which is for every carbon atom you have 2 times the amount of carbon atoms plus 2, and that will be the amount of hydrogen atoms. Here we have an example, some examples here. You can see here that there is only one bond between each carbon atom in each of the examples. And if you make the math, you can find that the amount of hydrogens per carbon will be exactly like in the formula. Let's continue with the alkenes. Alkenes are hydrocarbons that contain double bonds within the carbon atoms. You can identify them because the amount of carbon atoms is the half of the amount of hydrogen atoms. Here's an example. We can find the double bond in the middle between the 2 carbon atoms, and we can find that there are 4 hydrogen atoms and there are 2 carbon atoms, which means that there is the double of hydrogen atoms for each carbon atom. Let's continue with alkynes. Alkynes are hydrocarbons that have a triple bond between the carbon atoms. Here we can see it in these 3 examples. There is a triple bond in here also, and also in this one. So this will be like the key to find out which one is, and we can also use the formula to find out if it is or not. Let's now see what are the aromatics. Finally, aromatics are hydrocarbons that contain benzene rings.
Alkanes. In organic chemistry, an alkane or paraffin is an acidly saturated hydrocarbon. In other words, an alkane consists of hydrogen and carbon atoms arranged in tree structure in which all the carbon-carbon bonds are single. Alkanes have the general chemical formula, the alkanes ranging complexly from the simplest case of methane. To determine the steps to name alkanes based on the IUPAC system, we have to understand what an alkane is. An alkane is a hydrocarbon chain that contains no double or triple bonds between carbon molecules. The suffix at the end of the alkane should always be -ane. Then we have to draw out your molecule. You can draw out all the symbols, or you can use a skeleton structure, find out which one your structure wants you to use, and stick with it. Then we have to number the carbons on the parent chain. The parent chain is the longest continuous carbon chain in the molecule. Number it starting by nearest substance group. Each substance will be noted by its numerical location on the chain. And finally, we have to assign the name of the alphabetical order. Substance should be named alphabetically, not in numerical order. If you have to two of the same substance in the carbon chain put D before the substance even if they are attacked on the same number of carbon, listed number twice. One example of alkanes is pentane. The pentane is a linear straight chain alkane and has 5 carbon atoms, so N is equal to 5. We therefore use the general chemical formula where alkanes here CnH2 times M plus 1. So the alkane compound is called hydrocarbons, where the first 4 alkanes are methane, ethane, propane, and butane, and exists a Lewis symbol.
An alkene is an unsaturated hydrocarbons that contain one or more double covalent bonds between carbon atoms in a chain. The simplest alkene has 2 carbon atoms double bonded to each other. The general formula for the series is CnH2n. Their names are formed by changing the "-ane" ending to the corresponding alkane to "-ine". To name alkenes with 4 or more carbons in the chain, it is necessary to specify the location of the double bond. This is done by numbering the carbons in the parent chain, starting at the end of the chain that will give the first carbon in the double bond the lowest number. To name cyclic alkenes are named in much the same way as cyclic alkanes. However, carbon number 1 must be one of the carbons connected by the double bond. In alkenes, the parent chain is the longest chain that contains the double bond. The position of the double bond determines how the chain is numbered. Some unsaturated hydrocarbons contain more than one double or triple bond. The number of double bonds in such molecules is shown by using a prefix like di, tri, tetra, etc. before the suffix "-in". The positions of the bonds are numbered in way that gives the lowest set of numbers.
Alkynes are identified as organic chemical compounds that have triple bonds in their chemical structures. The way to identify them and name them, the first step will be count the number of carbons in the straight chain, and this will be the last piece of the name. Second, if there are double bonds in the chain, it will end with a prefix of E and E, and if they have a triple bond, it will end with a Y and E. Finally, we look at the substituent groups to check the positions of the groups and how many molecules are attached to this. And finally, we put all the 3 steps together and we can name our alkyne.
Hello, my name is Adrian Ramirez from Group 216, and today I'm going to explain you how to name aromatic compounds. So, aromatic compounds are substances that consist of one or more rings that contain alternative single and double bonds in its chemical structure. Here we have benzene, which is the simplest aromatic hydrocarbon. The chemical structure of benzene contains an hexagon ring with alternating double bonds. Here are 2 ways to draw benzene. The structure 1, which is this, shows how all the carbon and hydrogen atoms bond together. And the structure 2, which is this, shows a hexagon with alternating double bonds. In the structure 2, we have the edges of the hexagon, these ones, that represent all the carbon atoms, and the hydrogen atoms are not shown. So now let's see how to name an aromatic compound while I show you an example. First of all, I'll gotta tell you that benzene can also be shown as an hexagon with a circle inside. So the first step is to locate the main chain, which in aromatics will always be the benzene. Here we have the example, and our main chain is the hexagon with a circle inside, which is the benzene represented. Next, we locate the most important substituent and use it as the starting point. In our sample, in this case, the most important substituent is the chlorine. And well, we use it as the starting point, and we choose the closer path to the other substituents. Here we use the chlorine as the starting point, and we have 2 options, 2 directions. We can go downwards or upwards. In this case, we choose the upwards since we have the other substituent closer. Like we start counting, starting at chlorine, which will be the number 1, and methyl will be the number 2. Finally, based on the gathered information and the nomenclature rules of the hydrocarbons, you have the aromatic compound. So since we have the chlorine as the first one, we put 1 chlorine, comma, 2 methyl since it is in the second place, and finally the benzene.
In conclusion, I can say that this video really helped me to understand how to name hydrocarbons like alkanes, alkenes, and all compounds like that, and the importance of doing that in a very organized way.
Activity, I reinforced my knowledge about the nomenclature of naming all the hydrocarbons, and I also practiced my way of teaching something to someone.
So, in conclusion, thanks to this project I was able to understand more about the components of chemistry, and now I increase my knowledge about the subject of chemistry and how to make compounds with alkanes and everything about that. I increase my knowledge about some branch of the chemistry subject.
I believe that it's important to know how to identify different types of hydrocarbons and how to name them depending on their condensed formula. Because if you want to study a career that involves chemistry, you must be aware of how to do these procedures and how to follow the different steps to give the names to each of the compounds.
This practice was very useful because we learned the main definitions of alkanes, alkynes, and aromatics. It is also very useful because we can identify these 3 types in our daily life.
Making this video helped me to understand more the alkanes, alkynes, and alkenes.